Convergent evolution is when two unrelated lineages independently evolve a similar trait. Some animals converge upon so many traits they end up looking very much like each other. Famous examples include the resemblance of brontotheres to rhinos, how the reptilian ichthyosaurs converged on a body shape similar to dolphins and fish, and the similarity between ostriches and ornithomimosaur dinosaurs. The name of one ornithomimosaur, Struthiomimus, even means ostrich mimic. However, the ornithomimosaurs had their own lookalikes, the Shuvosaurids. Like them, they were bipedal reptiles with long necks, small heads, and toothless beaks. There are three named species of Shuvosaurids: Sillosuchus, Effigia, and Shuvosaurus itself. Just as the so-called ostrich mimics predate ostriches, the Shuvosaurids were long extinct before the evolution of the ornithomimosaurs. They lived over 200 million years ago during the Triassic Period, a time when dinosaurs were still uncommon. Despite their visual similarities, Shuvosaurids were more closely related to crocodilians than to dinosaurs. All such reptiles belong to the clade Pseudosuchia, which is united with dinosaurs and pterosaurs in the larger clade Archosauria. During the late Triassic, Pseudosuchians were actually more common and abundant than dinosaurs, and often looked similar to them due to filling similar niches. However, none converged upon a dinosaurian-like appearance more strongly than the Shuvosaurids. They belong to perhaps the most diverse branch of Pseudosuchia, Poposauroidea. The namesake of the clade, Poposaurus, was bipedal like the Shuvosaurids, but had the sharp teeth of a carnivore. The closest relative of the Shuvosaurids was Lodosaurus. Like them, it had a toothless beak, but it was a quadruped, with either a hump or a small sail on its back. Effigia was both the first Shuvosaurid whose fossils were excavated and whose dinosaurian-like nature was known to science, yet it was also the most recent one to be named. Its species name, O'Keefeae, is in honor of Georgia O'Keeffe, a famous artist who painted at Ghost Ranch, the site it was found at. The genus name, Effigia, means ghost, which is not in reference to Ghost Ranch, but how this remarkable archosaur had laid hidden right under science's nose for nearly 60 years. Over 1,000 skeletons of the theropod dinosaur Sillosuchus were preserved at Ghost Ranch, and when Effigia's fossils were excavated there in 1947, it was assumed it was just another Sillosuchus. The blocks which held the holotype were not even taken out of their plaster jackets until 2004, when they were noticed by a graduate student named Sterling Nesbitt, who has since become one of the foremost experts of Triassic archosaurs. He noticed some discrepancies in the Sillosuchus skeleton, and when he had finished preparing the blocks containing this Shuvosaurid, Nesbitt had a nearly complete skeleton of perhaps the strangest Pseudosuchian he had ever seen. It was quickly determined that several other mysterious reptiles were closely related to it, forming the clade Shuvosauridae. The namesake of the clade is Shuvosaurus, who was named in 1993 by Dr. Sankar Chatterjee. The fossils were discovered several years earlier by his son and Shuvosaurus's namesake, Shuvo Chatterjee. Before the description of Effigia, Shuvosaurus was thought to be an actual theropod dinosaur, and Dr. Chatterjee even believed it was an ornithomimosaur. This is in spite of the fact that true ornithomimosaurs wouldn't evolve until 60 to 80 million years later. A second theropod named after Dr. Chatterjee himself, Chatterjeea, was found to not only be a Shuvosaurid, but to be one and the same as Shuvosaurus. A paper released in 2007 came to the conclusion that Effigia was also the same animal as Shuvosaurus, but this hasn't received much traction within the field. The third Shuvosaurid, Sillosuchus, had been found in 1997. Named after the paleontologist Dr. William Sill, Sillosuchus was known to have been a Pseudosuchian from the onset, but it wasn't apparent just how dinosaur-like it was on account of its incomplete remains. Only its long neck had seemed out of the ordinary. Sillosuchus is found in the Argentinian Ixigualsto Formation, where it lived alongside some of the oldest dinosaurs like Herrerasaurus. The fossils date to around 230 million years ago, during the Carnian Age. Shuvosaurus's fossils date to the following Norian Age, and it is found in the southwestern United States. This was also the home of Effigia, although it lived at the very end of the Triassic period, either during the very end of the Norian Age or during the Ratian Age. Although they are only known from 3 named species, the Shuvosaurids seem to have been a long-lasting group. Besides Effigia and Shuvosaurus, Numerous isolated Shuvosaurid fossils have been found in North America, most dating from the Carnian to the Ratian ages. The oldest is from the beginning of the Middle Triassic, about 245 million years ago, 12 million years before the oldest dinosaur fossils. This means that these so-called dinosaur mimics evolved not only before the dinosaurs they most closely resembled, but even before the first actual dinosaurs. Altogether, the Shuvosaurids survived for nearly 50 million years, suggesting many more species of these toothless Pseudosuchians have yet to be discovered. The largest Shuvosaurus and Effigia skeletons are only 2 meters long, although they grew larger than this. All of the skeletons come from juveniles, and an isolated Shuvosaurid femur found in Arizona is 40% larger than those of the more complete skeletons. The Sillosuchus holotype is estimated to have been about 3 meters long when it died. However, it seems Sillosuchus or a contemporary Shuvosaurid could grow significantly larger. Re-examination of a neck vertebra once thought to have belonged to the apex predator Saurosuchus found it actually possessed the distinct morphology of Sillosuchus. This vertebra is 20 centimeters long, while the already elongated neck vertebra of the Sillosuchus holotype are only 8 centimeters long. This suggests the Shuvosaurid had a body length between 9 to 10 meters, an impressive size for its time. While the giant Shuvosaurid is often referred to as Sillosuchus, there is not enough material to determine whether it came from Sillosuchus or a new species of closely related Shuvosaurid. Either way, while they are usually perceived as small, gracile creatures, it seems Shuvosauridae included some of the largest animals of the Triassic period. Large or small, Shuvosaurids closely resembled ornithomimosaurs and modern ratites like ostriches. The skulls of these archosaurs were small and lightly built, with their toothless jaws supporting a beak. This shape is also shared with an obscure, toothless ceratosaur dinosaur named Limosaurus. However, Shuvosaurid beaks were broader, yet shorter than those of their dinosaurian counterparts. In another case of evolutionary convergence with ornithomimosaurs, these bipedal crocodile cousins had large orbits and presumably large eyes. Additionally, their necks were exceptionally long by Pseudosuchian standards. Like theropods, the limb bones of these dinosaur-like archosaurs had thin walls, to the extent their fragments can be mistaken for those of theropods. However, this trait is also present in some other Triassic Pseudosuchians, including the direct ancestors of Crocodilians. A more notable case of convergence between theropods and Shuvosaurids was their sacral or hip vertebrae. Archosaurs ancestrally had 2 sacral vertebrae, and Triassic Pseudosuchians usually had no more than 3. On the other hand, early dinosaurs had 5. Shuvosaurids had 4 sacral vertebrae, right in between those of the Pseudosuchians and basal dinosaurs. Also, like theropod dinosaurs, these vertebrae had fused together into a rod-like structure. Most Pseudosuchians had osteoderms, bony plates which grew in the skin. Modern crocodilians used them for a variety of purposes, including as armor, for thermoregulation, and as mineral reserves. Both the Shuvosaurids and most dinosaurs lacked osteoderms. Shuvosauridae was not unique in this regard, since most other pulposauroids also lacked them. The only exception was the basal pulposaurid Chienosuchus, although its osteoderms were already smaller and fewer in number than most other Pseudosuchians. Despite being a remarkable case of convergent evolution, beneath the superficial similarities, these bipedal archosaurs had more anatomical features in common with their fellow Pseudosuchians than with dinosaurs. This mirrors how crocodilians have more in common with birds than the superficially similar but more distantly related lizards. The trait that initially tipped Dr. Nesbitt off about Effigia's Pseudosuchian identity was its ankle configuration. While dinosaurs like Silophysis have simple, hinge-like ankles, the astragalus bone of the Shuvosaurids and most other Pseudosuchians fits into their calcaneum bone. This is called the crocodile normal ankle, and it allowed Pseudosuchians to both hold their legs directly under their bodies like dinosaurs, while also offering them more flexibility. In another departure from their lookalikes, Shuvosaurids had 4 large toes on each foot, unlike theropods who only had 3. Compared to theropods, Shuvosaurid torsos also extended further from their hips. Combined with their much shorter legs, it is doubtful that Shuvosaurids could have run particularly quickly. This stands in contrast to the exceptionally fast ornithomimosaurs and ostriches. Shuvosaurids also had short arms. They clearly functioned very differently from the long arms of ornithomimosaurs, but they were still likely capable of grasping plants, unlike the vestigial forelimbs of Lemusaurus and the wings of ostriches. Shuvosaurids had an intermediate or mesothermic metabolism. This would have allowed them to be more active and grow faster than crocodilians. Even though crocodilians are ectothermic, the higher metabolism of the Shuvosaurids was not actually the result of convergent evolution. Archosaurs ancestrally had a high metabolism. Crocodilians have reverted to a lower metabolism more in line with most other reptiles, while the metabolism of the dinosaurs continued to rise, eventually culminating in the endothermic metabolisms of today's birds. Although they were lower than those of the contemporary dinosaurs, Shuvosaurids had higher metabolic rates than most other Triassic Pseudosuchians, with the direct ancestors of crocodilians being a notable and ironic exception. Because of their similarities, it was assumed that Shuvosaurids lived much like ornithomimosaurs and ratites like ostriches. Indeed, it was once hypothesized that they may have even pecked food off the ground like their modern lookalikes. A later paper used finite element analysis to model the effects of different feeding strategies on Effigia's skull. While it was found to be a plant eater like its dinosaurian counterparts, Effigia's skull was not durable enough to handle the stress created when pecking. Although it theoretically could have had the jaw muscles for a powerful bite, its mandible was too weak to withstand such force. Indeed, the authors concluded that Effigia was likely restricted to cropping soft plants with the front of its beak. Overall, despite their visual similarities, Shuvosaurids seem to have filled entirely different niches than either ostriches or ornithomimosaurs. The authors noted that for all the traits they converged upon, their differences had been largely underappreciated when trying to determine how they lived. With their long necks, the Shuvosaurids would have been able to consume higher foliage than most other Triassic herbivores like Dinosaurs or Dicynodonts. The particularly massive Sillosuchus may have been the most accomplished high browser the world had yet seen. In this regard, perhaps the best ecological comparison for the Shuvosaurids among the dinosaurs are not the visually similar ostriches or ornithomimosaurs, but contemporary sauropodomorphs like Plateosaurus. During the Triassic period, sauropodomorphs were not present in North America, where most Shuvosaurid fossils have been found. Sillosuchus coexisted with some of the earliest sauropodomorphs in South America, but these dinosaurs were still small, and few were even dedicated herbivores. This could suggest these high browsers competed for the same resources. Models of the thermodynamics of Triassic fauna have found large sauropodomorphs were vulnerable to overheating in the warmer equatorial regions of Pangaea, likely explaining their absence there. However, large Pseudosuchians would have been just fine in such temperatures due to their lower metabolic rates and therefore lower body temperatures. Notably, Shuvosaurids were not restricted to the warmer regions, since the environment preserved in the Ischigualsto Formation alongside Sillosuchus was actually quite cool. Still, any ecological overlap between these dinosaurs and Pseudosuchians would have been limited, since Shuvosaurids seem to have been restricted to cropping softer plants, while the sauropodomorphs could feast upon a broader variety of foliage. The Shuvosaurids are one of the most extreme examples of convergent evolution, but they also serve as a cautionary tale that even the most dramatic cases of convergence do not always translate to similar lifestyles. The Shuvosaurids differed from their later lookalikes in many respects, just as there were many differences between ostriches and the extinct ostrich mimics. Still, their genuine similarities display the great success of their shared body plan. Both Shuvosaurids and ornithomimosaurs only perished during devastating mass extinctions. Given how few species of Shuvosaurids have been described despite their long existence, it is clear much more remains to be learned about these unusual bipedal archosaurs.
Thank you for watching, and a thank you to the Metallorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.